Hello everyone. In this video we're going to begin to talk about section 3.3, which is properties of functions. So the first property that I want to talk about is the evenness or oddness of a function. Okay, so what does it mean to be an even or an odd function? Well, an even function is a function, a function is an even function if for every number x in its domain, the number negative x is also in the domain, and f of negative x is equal to f of x. Okay, so now that first part, that every number in the function's domain, that negative number is also in the domain, that is an important part of being in an even function, but it's not something that we are really going to consider in this course. It would be something that you consider in a further course. So you don't really have to worry about that. What you have to worry about is, does this condition here fit or not? Okay, and it says that if I substitute negative x into the function, it's going to look the same, exactly the same as if I substituted an x into the function. Okay, and now sometimes that function I might have an x in there already, and so then you just have to check if negative x, if I plug that in or substitute that in, it looks the same as the original function or not. Okay, so that's even. An odd function is a function, a function is an odd function, I do that every time, if for every number x, the domain, in its domain, the number negative x is also in the domain. Again, important, but not really what we're going to focus on here. And f of negative x is equal to negative of f of x. Okay? And so again, this is the important part here, that this equation sort of works out. Okay? And so we're going to have practice on looking at functions and seeing if they are even or odd, but that's the important part, those two equations. Okay? And then there's another theorem that helps us look at a graph of a function and tell if it's even or odd or neither. Okay? So a function is even if and only if its graph is symmetric with respect to the y-axis, okay? And a function is odd if and only if its graph is symmetric with respect to the origin. Now, I'm sure that doesn't make much sense at all because that's a very technical definition, but we're going to look at two graphs in just a second that are even and odd, and hopefully it'll explain what this theorem is saying. Okay, so here we go. I want to determine if these two functions, these two graphs here, graphs of functions, are even functions or odd functions. Now, that theorem said that a function is even if and only if the graph is symmetric about the y-axis. What that means is if I draw a line, and I'm going to make this line bigger, if I draw a line here at the y-axis, okay, that big red line, and I flip one side of the graph over on the other with this is like my cutting point. So I cut it down the middle, and then if I take this left side and flip it like a book over on the other side, then everything, there's only one line left over. Okay, so when I do that, if I did flip this part here, okay, that blue line, if I flipped it over, it is in fact, going to draw the exact same as this right side. Okay, it would go exactly on that, the right side of that function. That's what it means by being symmetric. So if I could cut it down the middle and flip it over and everything overlaps, then that function is even. Okay, so this example, this function here, try to erase all of this, this is even. This is an even function. Okay, if I can cut it down the middle and flip this side over and get full overlap, then that's an even function. That's what it means to be symmetric about the y-axis. Okay? Now, for an odd function, and I'll get this out of the way and say this bottom one is an odd function. Okay? It said it's symmetric about the origin. Okay? Symmetric about the origin, and that was probably especially confusing. But what that means is I need to be able to flip over the x and then the y-axis. Okay, so I need to flip. So if I look at this curve here, this part of the curve, if I flipped it up here 90 degrees, so if I flipped it over the x-axis first, there, okay, I flipped it up, it's going to look like that, roughly, okay? And then, if I flip it over the y-axis this way, then does it overlap? So it has to flip over the x and the y-axis and get overlap if it's an odd function. That's what it means to be symmetric about the origin. Now, of course, you could flip over the y, then the x. You just have to go x, then y. Okay, but that's the way I did it. Has to flip over both. That's my dog whining, if you hear something odd. So those are even and odd functions graphically. Let's look at even and odd functions algebraically. Okay, this was the first part that I told you was important. Okay, determine if even and odd functions, if a function is even or odd algebraically. So the first function that I want to look at is over here, g of x. Okay, and it's x cubed minus 1. Now, this is not a foolproof piece of advice, but generally, if I have a polynomial, or if I have like an x term with an exponent that's odd, there's a decent chance that it's going to be an odd function. Okay? So let's start and check if this is an odd function. So what an odd function says, or what that thing at the beginning said, is a function is odd if f of negative x is equal to negative f of x. Okay? So let's see if that is true. So, and I'm sorry, this says f, but that can be easily changed to g. Same thing. Okay, so what is g of negative x? Well, I substitute in negative x here, negative x cubed minus 1. And so if you look, negative x quantity cubed, okay, that's negative x times negative x, and that means there's two negatives there, they cancel out, and that would give me positive x squared times negative x again. So what do I mean by that? Negative x cubed is really like rewriting negative x times negative x times negative x. That is negative x cubed, okay? And then we'll add the minus 1. You combine these two to get positive x squared times negative x minus 1, and then you get negative x cubed minus 1. Okay, so that's g of negative x. What is negative g of x? Well, it's negative 1 times x cubed minus 1. And so when you distribute, you get negative x cubed plus 1. So, is this condition up here met? Are these two equal? And the answer is no, they aren't. Okay, one has -1, one has +1. So it turns out x cubed minus 1 is not odd. Okay, and we already even, so we checked if it's odd. What if we check it's even? Even if f of negative x is equal to f of x, okay, or g of negative x and g of x. Sorry, have it with f. We already found g of negative x. It is down here, negative x cubed minus 1. Is that the same as x cubed minus 1 here? No, so it's not. It is neither even nor odd. Okay, it's neither. So there is a neither option. Okay, so that's the first one, neither even nor odd. Now we'll move on to the second option, okay, or the second example. F of x equals capital, so capital F, but it really doesn't matter, but they're just letters out in front, okay, is this. So hopefully you've seen this before. It is the absolute value of x, okay, and the absolute value function, what it does is it turns everything positive. So if you have a negative number, it's just going to get rid of the negative sign and make it the positive of that same number. Okay. Graphically, although I draw terribly, there's my xy plane. The absolute value function looks like that. Okay, it's a v. It's a v starting at 0, 0, and then it goes up at the same rate on either side. So from our last set of slides, or the last slide that we were on, you should have a pretty good idea of what property this function has, even or oddness. Okay, and the hint is that it's even. So let's check if the even condition is met. So is f of negative x equal to f of positive x? Okay, and so we have to evaluate this left side. We already have the right side up above, right here, okay? And so f of negative x is equal to the absolute value of negative x. And what I said the absolute value function is, or the absolute value function does, is it gets rid of this negative right there, okay? It gets rid of that negative, and so I'm left over with the absolute value of x. Okay, I could write that as just x, okay, but that might be a little bit confusing because you say, well, f of x really is the absolute value of x. So the question is x equal to the absolute value of x? And the answer is yes, it is. Okay. Or never mind all this. Okay. The negative, the absolute value takes away that negative sign, and you're left with this. Okay. That makes it much easier. Just forget the last 30 seconds of what I was saying. So we've got f of negative x equaling f of positive x, and so this function is even. Okay, so to practice that, here's your turn. Okay, determine if that function f is even or odd algebraically. Okay, and so what that means is use the formulas that I was talking about on the last slide.